Welcome to Maths e-Learning. Today you will see limits and their properties. I am going to show you how to use limit properties to calculate the limits. First approach for the limit always direct substitution, but this works for only some functions. If the function is a continuous function, then we can use the direct substitution to find out the limit. For example, limit f of x goes to c equal, just go and replace x with c. So that will give you the solution for the limit. Now in this slide you can see some of the properties of limits. What are the basic properties of limits? For example, if we want to find out the limit of any constant value, if x goes to any value, that is always the same constant value. If we want to find out the limit for just x goes to any constant value or 0, the answer always that particular value c. If it is a power function, the power function always continuous function, then we can apply the direct substitution x to the power of n, x goes to c equals c to the power of n. Here we'll see some example for each category. When limit 3 x goes to 2, the answer is 3. According to our property, we can say the answer is 3. So the solution for this 3. The next one, limit x goes to minus 4, the answer is minus 4. If it is a power function x squared, just replace this x with the limit value 2. So this turned out to be 2 to the power of 2 equal 4. These are the some of the basic properties of limits. We'll see how can we represent this as a graph. The first one, if it is a function 3, we can represent f of x is equal to 3. Thus a horizontal graph goes through the point 3. If we want to find out any limit at this x-axis, x goes to 0, 2, 7, 9 or anything, the value always 3. That's the first property. The second one, if it is a function f of x is equal to x, when x goes to any value, that will give you the same value as x goes to. X goes to minus 4, the answer is minus 4. If x goes to plus 10, the answer is plus 10, according to our property. Number 3, if it is a power function, you can see the graph, just you have to replace x with the limit value 2. So x squared turn out to be 2 squared equal 4. That's the explanation we can use the graph. Next, I'm going to list all the limit properties one by one. The first one, if c is a constant and the function f of x goes to a is equal to L and g of x goes to a is equal to m. If it is like this, we can say what happened to addition and subtraction. F of x plus g of x goes to a, just we can represent this as L plus m. If it is minus, we can call L minus m. Next property, multiplication. F of x times g of x. X goes to a. If you have a value L and m, just go and multiply and give the solution L times m. Next, when it comes to division, same as multiplication, but only one thing you have to remember, the denominator does not equal to 0. If it is 0, the value does not exist. The next, the constant multiple of that function, then we can take the constant outside and apply the limit f of x goes to a is equal to L, just c times L. The same as the power function, we can take the limit inside of the power function and L the power of n. Next, if the constant, I already explained to you what happened to the constant value. That's the same as the limit x goes to a. The power function x to the power of n, and the last one is the square root function. It's same as the power function. We can take the limit inside the square root. The answer is square root of L. Only one restriction you have to know, L always greater than 0. When it comes to square root, always we can apply the positive value inside the square root. Next, we'll see how we can apply the limit rules to get the solution. The first example, limit x goes to 3 x squared plus 1. We can separate this as two limits. So using addition rule, we can separate this into limit x squared and limit 1 x goes to 3. Then we can apply the power rule and the constant rule to find out the solution. The answer is 10. But without using the limit properties, we can go directly to this answer using direct substitution. Because x squared plus 1 is a continuous function, we can apply the direct substitution and get the solution of 10. The same as the second example, we can separate this into two limits and then take the limit inside the square root function and get the solution for that. Or directly we can apply the direct substitution and get the solution of 1 over 8. Depends on the question, if they ask you to use the limit properties or just find out the limit, either way you can apply and get the solution. Next example, if it is the square root function x goes to 2, we can do direct substitution or use the properties and get the solution of square root of 6. Now your turn. If you get the answer of 2, you are done. If you don't get it, please try it again. Next, some of the other type of questions you can see here. If they provide the limit f of x and g of x, how can you evaluate some of the function without giving the exact function? Like g of x and f of x, some multiple addition, multiplication or the division. The first one you can see here, we can take limit inside and we can rewrite this as 5 limit g of x. X goes to c. Then we know the answer for limit g of x goes to c is equal to 3. So the answer is 5 times 3 is equal to 15. Same as for the addition, we know the addition rule already be stated under the properties of limit. We can rewrite this as 2 plus 3 is equal to 5. The next one is the multiplication. So that is 2 times 3 equal to 6. And the last one is the division. So that is 2 over 3. We are done using the properties. The next one, the same, only one function provided. We have different types of questions. Power function, square root or the constant multiple. Still, we can apply and get the solution for that. So we can take the limit inside this function. So that is 4. The answer is 4 cubed. The next one, we can take the limit inside the square root. Square root of limit f of x, that is 4. Square root of 4 is equal to. The next one, we can separate this as 3 times the limit f of x equal 4. The answer is 12. The last one, we can take the limit inside. So the answer is 4 the power of 3 over 2. Then you can apply the radicals. 4 the power of half equal 2. So that is 2 cubed equal 8. So next example, if p is the polynomial function, any type of polynomial function, we know that polynomial functions are continuous functions, so we can apply the direct substitution to get the solution for that. You see here, we can apply the limit rules or we can apply the direct substitution. When you go and apply directly, you will end up with 4 times x is equal to 2 squared plus 3. Then you will get the same as the limit rules, answer 19. The next example, if it is a rational functions like p of x over q of x, still we can apply the direct substitution. When you apply x is equal to 1, you will end up with 1 squared plus 1 plus 2 divided by 1 plus 1. So the answer is 4 divided by 2 equal 2. Next, if it is a square root function, still we can apply the same approach, the direct substitution. Square root 7 plus 2. 5 times 7, 35 divided by square root 9. So square root of 9 is equal to 3. So the answer is 35 over 9. Next, if you have a composition of two functions like f of g of x or g of f of x, still we can apply the direct substitution and get the solution for that. For example, if it is like this, the first step, we can take the limit inside of the function f of x and get the solution of that, and then apply and get the solution for that. So this one is g of, when you take the limit inside and the function f of x, x goes to 4. Then it's easy to get the solution for that. G of, when you apply x is equal to 4 to this function, you see 2 times 4 squared is 16 minus 3 times 4 plus 1. This equals g of, you can simplify this, so 32 minus 12 plus 1. So this equal to g of 32 minus 12 is 30, 20 plus 1 is 21. Then go and apply g of 21 into this function and get the solution for that. So those are the limit properties you have to know. Now you understand how to apply the limit properties and direct substitution to get the solution for that. Thank you for watching. See you in another video.